All right, what is up, you pod heads? Today we're going to do something a little bit different. We're not going to do an installation of speaker pods onto a door panel. Today we're going to test speakers. Why are we going to test speakers? Why not? So let me run you through what the plan is. The plan is today we're going to test this DS18 Pro ZXi 8-inch. It's an 8.4 with the bullets, 4 ohm. These are the speakers I'm running in my car right now. The plan is to see what this speaker can do, not only at the measured responses, all the stuff you see in the data sheets and all that little frequency response graph. We're going to test this at volume to see how it performs with power on it. Now, the other thing we're going to do is we're actually going to test it in the door. We're going to see how installing a speaker into a speaker pod changes how the speaker performs. An we going to do that? Great question. First thing we're going to do is we're going to put it in my box. I built this box to simulate an infinite baffle. Why is that important? We'll go over it in a future video, but basically a door is an infinite baffle because it is either A, not fully enclosed, or B, not fully ported, whatever. It's a leaky box. So we're going to assume that it is a infinite baffle for the purpose of testing. It's going to make all the calculations easier, the estimations and the theories a little bit easier to understand. So in my box, I have some acoustical foam to reduce the back waves and resonances. I've tested that. I can show that in another video if you're interested. But basically, this box traps all the back waves, so the only thing we're hearing is what is coming directly out of the speaker itself, which is pretty cool. So I am powering it with a DS18, GFX, something or other. I'll put the specifics in the comments. But basically, it has the capability of putting out 100 watts RMS with a clean, non-clipped signal. And I say 100 watts is 19 volts. Go over that later too. It is being powered by a Retro 56. And I have a UMM6 from Dayton Audio that we'll be taking the measurements with. And I am powering all of that with my laptop powered by Room EQ Wizard, or ROO, going through an M Audio M-Track Solo, basically a digital to analog converter. Cool? Awesome. So first thing we're going to do is we're going to test it in the box. That is going to give us a baseline response to see what the speaker can do, not only at low wattage, but a little higher wattage as well. Next thing we're going to do is we're going to install it into this door panel, which has a single 8. We're going to put that into my car. Then, for the piece de resistance, we're going to install all 4 speakers into these pods, crank it up, see what it does. How do the speakers interact with each other inside a pod when there are multiple speakers installed? How do they act at volume? We're going to find out. We're going to use data. We're going to use measurements, calculations. It's going to be a whole lot of boring fun. Let's get started. One thing I forgot to touch on was why. Why are we doing this? We're going to do this because we can plan out system on the computer without testing a speaker before we buy anything. I'll show you how to do that too. It's super cool. Some other guys have done it. Copying what they did. I will, Nick from Resonix, I watched his video. And then a big shout out to Narius over at Rawcat. Dude is a genius, and he has been putting up with all of my stupid questions regarding all of this stuff. So if you haven't checked out either one of those channels, please do so. Yes. All right, so this is Room EQ Wizard. We're going to be using this software to measure everything speaker related going forward. So first thing we're going to do is we're going to take a sweep test. We're going to rename this, make sure that it is named correctly so we can see the data. Pro ZXi at 1 volt. We're going to be running a sweep from 20 to 20,000 hertz. Checking that it's at 1 volt and go. So that there's a frequency response of that test. We're going to run another one. And we're going to increase the volume a little bit, put some more volts to it. We're going to run this one at 10 volts. And go. There's 10 volts. We'll do one more at 20 volts. And go. Earmuffs. Alright, we have those 3 tests. Next thing we're going to do is we're going to do a RTA, real-time analysis. Basically, we are going to measure the speakers as they play a pink noise. Yeah, generate tone, pink random, and we'll do this at 5 volts. Go. That window over, a little more. Record and go. So what we're doing here is making sure we get enough measurements, make sure that that line, the red line, which is the peak, stops moving so we can get the most accurate reading. And stop recording. Stop the noise. Save the peak. Very good. One more test. We're going to do a reset averaging. We're going to do a test of a song, Baby No Money. E-Girl Anthem, first 15 or so seconds to get enough data, just for fun. Back over here, open the RTA and record.
Oh, that's fire. Baby, no money, gonna get that money, gonna get that money, gonna get that cheese. Baby, no money, gonna get that.
Alright, get enough data. We're gonna go ahead and stop recording, stop the song, and that's it. So now we have that. We're gonna go save the peak, back into the main screen, and then we're going to rename these. This one is the pink noise, rename that pink, and then we'll rename this to test track. So just a quick rundown of the inside of the door. This door has already been deadened a little bit, a lot of it. Basically covered up all the holes with deadener, and I did a couple layers inside the door cavity itself. But the door panel itself has not been treated at all. Don't mind the dust and stuff. That's from something completely different. Alright, so I got speaker installed inside the pod, inside the door panel, inside the car. Still everything being powered by the DS18 amplifier and powered by a Room EQ Wizard. Microphone is the same distance away from the speaker. We will perform the same exact tests so that way we can compare the data. Off we go. Okay, so now we have all of these beautiful squiggly lines in WinISD. We have 3 sets of measurements. Basically, everything that is in red is the speaker in my box. Everything that is in bluish is the speaker in the speaker pod in the door of my car. And then anything in green is the speaker in the speaker pod in the car with the door closed and the microphone in the headrest.